Welcome to all. Engineering Mechanics, class 42. As I told earlier, till the subject is over, I will continue this number. Last time, little earlier, around 4 weeks earlier, I completed part 1, where there were 41 lectures. Part 1 was forces, moments, and other resultant. That was part 1. And then I uploaded one more class where I gave details of the notes. Now I am starting to issue the notes for those who register for it. Notes will be sent for those who register, as I explained there. Now I am starting part 2. Here it is equilibrium, different types of loads and support reactions. Remember, this part 2, first of all, everything is important. But this part 2 is very, very important for entire structural engineering. Later, when you go to strength of materials or structural analysis, determinate or indeterminate, then all this will come repeatedly. Like equilibrium condition, different types of loads, point load, UDL, UVL, etc. Then support reaction, fixed support, hinged support, roller support, simple support, everything will repeat. So this will be taken in detail part 2. Now lecture 1, see I told this will continue. For part 2 this is lecture 1. What I am covering now is basic conditions of static equilibrium for a 3D force system. Now, but before that, there are some statements. I had decided one thing now. In the class, I am not going to write too many statements because, see, 41 lectures for that part 1 is too high. Therefore, that is because I used to write many things. Anyway, I decided everything I tell in the class with the extra information I write in the notes. And all the problems solved in the class plus much more extra problems and also some exercises, homework type, I am writing in the notes. Therefore, in the class, I will now onwards, I will start dictating. Those who are not going for the notes, they have to listen and write. Don't tell it not written. Or you have to go, or if you take the notes, then everything will be there. I will upload one more class for this purpose because I have to give information. Because some may not listen what I am telling now. It happens. They fall. When I explain something, they go forward. General tendency nowadays, people fast. They do not want to listen anything. Okay, leave it. So one more class I will upload for that one. That is what way class will be continued for entire engineering mechanics, strength of materials and also structural analysis. Okay, start now. Before you start anything here, some statement. Consider a body. See, usually when you show body, we write something like this. But I want to show a 3D body, 3-dimensional. Now what I have to do is, I have to show something like this all. Instead of that way, I decided better show like this. Remember, the shape need not be like this. It can be, make a note. Consider a body of any shape, regular or irregular. It does not matter. See, statement. These all, those who are depending on the class, everything I tell, you have to write. Consider a body subjected to any, or not any, a general force system in 3D, in 3-dimensional, right here. Consider a body subjected to any general force system in 3D. 3D means some people call what? In space. Force system in space means make a note. X will be there, Y will be there, Z will be there. See, force can be this way, force can be this way, force can be this way, couple can be like even force system means not only force, couple also possible, anything random. Couple can be this way, couple can be this way, or couple can be this way, anything. Now, we are considering equilibrium. See, don't go for other things. Equilibrium, right here. A body is said to be in equilibrium if it does not move and also it does not rotate. There should be no translation, means movement, and no rotation. When a force system is acting on a body, what will happen? If the resultant force of the force, you should write all these things. In the notes I will put sketches. If the force system, suppose it reduces a resultant force. If the resultant force passes through centroidal axis, that is axis passing through center of gravity of the entire body, then it will give only translation. See, this way. But if it is the line of action, if it is not passing to center of gravity, if it is eccentric, if it lies outside CG, see here, if the resultant goes here, see now, it will move and also rotate. Therefore, even if the resultant is a force, it can cause rotation. If the line of action of resultant passes through center of gravity, there will be no rotation, only translation. But if it is outside center of gravity, it will create a couple. See, it will, see, if I apply here, it will move no doubt. See, it will move and also rotate. Or if the resultant force vanishes, resultant is a couple. The resultant couple can be either like this. See, 3D resultant force can be either like this, or like this, or like this, or inclined also. Couple can be any way. If there is resultant couple, in 3D, there are possibility of 3 couples. This all I will explain later. Then, if the resultant is couple, body will not move, it will rotate. Okay. Now, this all you write here. In the notes, I will put all this by sketches. Now, for a body to be in equilibrium, just now I told, it should neither move nor rotate. For body not to move and not rotate, conditions. Not to move. Usually, force will cause movement. See, force will give translation. It can give rotation also. Couple will give rotation. Therefore, make a note here, for any body subjected to a general force system, for no translation, neither translation nor rotation, that is equilibrium. It will remain as it is. It should neither move nor rotate. For that one, resultant force should vanish. Resultant force should vanish. Should vanish. And also, right here, resultant couple should vanish. Couple should vanish. Should vanish. There should be neither a force resultant nor a couple resultant. If force resultant comes, tendency is to move. If couple resultant comes, tendency is to rotate. None of them is permitted. See, when a body is in equilibrium, no force, resultant force. Now, go further. Consider reference axis XX. See here, XX. YY. ZZ is perpendicular to the board. This is as per STAAD.Pro software. Some software like ETAP, they take XX here, they take this YY, this ZZ. But usually, when you study engineering mechanics or strength of materials or structure engineering, general practice is lengthwise XX horizontal, horizontally widthwise Z, horizontally lengthwise XX, vertically is YY, and horizontally widthwise is ZZ. Now, see now very important. Therefore, one more statement. For the equilibrium for the given force system, there should be no resultant force in X direction, in Y direction, or Z direction. That is resultant force in X direction, or if resultant is inclined, its component along X, along Y, along Z should be 0, or resultant force should vanish. Also, for the body not to rotate, moment, algebraic sum of moment, or couple you can call. If moment is there, it is called couple sometimes. About XX, see, when you consider moment, it is always about an axis. But in coplanar system, you tell about a point. This I explained earlier. Go back earlier, study it. But I'll explain once again later. So when you study or when you consider 3D force system, moment is always about axis. Remember, always about an axis, not about a point. In 3D, moment is always about an axis. Means, see, x-x axis. Moment about xx. Or y-y axis. Moment about yy. Z-z axis. Moment about zz. This all I will explain slowly one by one. All should be zero. Therefore, right here, basic conditions of static equilibrium. Why it is called static equilibrium? Statics means body is at rest. So make a note. Therefore, the basic conditions of static equilibrium for a 3D force system or force system in space is, see, I used green color for axis here. So sigma fx0, sigma fy0, sigma fz0, then sigma mx0, sigma my0, sigma mz0. These are called force conditions. These are called moment conditions. This is to prevent translation. This is to prevent rotation. I will tell once again. Now I have put waves here. See, waves here. Explanation I am giving, but not writing. Space is not there. Sigma fx equal to 0. That is, right, algebraic sum of the components of all the forces along xx axis should be 0. Sigma fy0, algebraic sum of components of all the forces along yy axis is 0. Sigma fz0, algebraic sum of forces, algebraic sum of components of the forces along zz axis should be 0. I will tell once again, x means what? It can be that side or this side. Plus minus will come, but x, both sides I am writing. So, see, sigma fx0. No algebraic sum of the forces in this direction. Sigma fy0, 0 in this direction or along this axis. Sigma fz0, this way, 0 over. Same way, for preventing rotation, sigma mx0, see, you should write algebraic sum of moments of the entire force system about xx axis should be 0. Same way, algebraic sum of moment of the entire force system about yy axis should be 0. Algebraic sum of moment of the entire force system about zz axis equal to 0. So now I will rub everything here. I will give conclusion, will not repeat once again. See, equilibrium means at rest, neither a translation nor rotation. No translation this way, no translation this way, no translation this way. Moment, no rotation this and no rotation this way, no rotation this way, and no rotation this way. I will explain the axis later. These are three conditions for forces. These are three conditions for moment. Altogether, there are 6 number. Remember, there are total 6 conditions. 6 conditions of static equilibrium for a force system in 3D or a space system. Okay, now, I will need not tell again and again same thing. Rewind or go back and listen once again. So now I will rub everything and start this explaining some moments about forces. I will explain these terms and these terms briefly. I will explain after rubbing. Okay, now little more explanation. In the class I will explain, but dictation. See, just to give more idea. How is fx, how is fy, how is fz? See, For fx, fy, fz, remember, you have to always consider along. Remember, along. For then how is fx? Now I'll write here, how is mx, my and mz? For that, you have to always consider, see right here, you should write always consider along. See, for force, it is always along. For moment, always consider about. Right now, about an axis. Which axis I will tell you. But when you go to coplanar force system, actually there also it is about, it is also about an axis, but it is simplifies to about a point. This I told you earlier. If you remember, this I explained earlier. You should go back and study in my class. If you want to understand everything, you cannot lag behind. Everything, make a note, repeatedly see what classes are uploaded. You should go through it again and again if you want to really master. Okay, now start. Fx, force along x. See, either this way or this way. No plus minus. Later, if I take this positive, for this one, we will use negative sign. But still now, right now, no sign. Okay. Along xx here, along xx, this way or this way. Along fy, either this way or this way. Along zz, I can't show it here. See, either this way or this way, perpendicular to the board. Moment, mx. I already explained, see, moment, how to decide. See, if the moment is like this is the axis. If moment is like this is the axis. If moment is like this is the axis. Go back to earlier class. I told hint for you, definition, a body, how to define the axis as per physics and also engineering mechanics. Now if you do not follow correctly, because you have not gone to earlier, it is your problem, not my problem. My effort will be to give complete structural knowledge for those who are really willing to study or who deserve it. Non-deserving people, I am not bothered. Sometimes I am very harsh. My age, how much effort I am putting, if you think that much, it is sufficient. Okay. Now see, I told you axis. See, and once again, see, axis. 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 Okay. Now, see now, if it is x-axis here, I cannot show it actually. See, it's actually like this. We cannot show it. So simply see, this way clockwise or anti-clockwise, mx. See here, my, either clockwise or anti-clockwise. See, about this one, mz, or just to understand, take here. Now this is a cope in a plane. If a couple is acting here, now only clockwise I am showing, or this way and this way. See correctly now, see. Correctly decide once again. XX, YY, ZZ. Therefore, see now, if I apply a couple here, see correctly how I apply a couple. Make a note. See. I apply the couple now. See. If this is the couple applied, this is the axis, mx. See, then, see here. My and mz. Now, one very, 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 very important note. I will give after this one. Consider only mz little later. Now, little later, we will consider we will consider mz. Very, very important. Reason, I'll tell you later. This is special for us. This is special for us. I will tell the reason after writing everything here. I will explain. Now consider basic conditions of static equilibrium for a coplanar force system. Remember, one note you have to write. We will not be solving any question for force system in space. It is highly complicated. And space structures also we will not solve. So from in engineering mechanics, strength of materials, and also in structural analysis, we will always consider coplanar force system. Manually, that's all. Space system usually will be solved by software. Understanding point of view, coplanar. Now, coplanar means force system, coplanar. We will consider force system in XY plane. In XY plane. XY plane means, see here, this is X, this is Y. This plane is called XY plane, or see here, a plane I mark here. This is X, this is Y. Remember, this is Z, I am not writing. This is, see, this is XY plane. If a couple is acting here, see, if a couple is acting here, it's a couple in XY plane, see, correctly. This way. Couple in XY plane. See, couple in XY plane, but it is about ZZ. Not, it is neither MX nor MY, it is MZ. It is MZ, or, see, it is about this axis, see, this axis. Now you can do one thing. In the plane, you can see a point. Therefore, first of all, this already I told earlier. So now I will not waste time. Therefore, MZ can be considered as, I will not tell again and again, moment about, see, if I take a point here, if I take moment about this point, see, this way, it is about Z. So Z you cannot see. So remember, I will not repeat, MZ can be considered as a moment about any point, not axis, any point in the plane. In the plane. Therefore, instead of writing MZ, we will now onwards simply write, no reference, simply write moment about any point in the plane. So last I will tell, if you tell moment about any plane, moment about any point in a plane, it is actually moment about an axis perpendicular to the plane. So see, perpendicular to the plane passing through that point. Therefore, see, we will not use the term MZ now. We will not call MZ. We will simply call M. That is, instead of sigma MZ equal to 0, now onwards, we will simply call sigma M equal to 0. Of course, sigma Fx, sigma Fy are there. We will call sigma M equal to 0. Over. Now, I will write equilibrium condition for, I will not repeat once again. I already told so many times. See, now, write equilibrium condition for a coplanar force system. Okay, same thing. This all I remove now. I'm not clearing the board too much because it's the ending part of this one. Therefore, see. Now consider basic conditions of static equilibrium for a coplanar force system. Remember, for a coplanar force system, right here, we will consider XY plane. XY plane means forces can be either along X or along Y. And moment will be like this, about Z or about a point. Sufficient. Therefore, conditions are coplanar force system in XY plane are sigma Fx equal to 0, sigma Fy equal to 0, and sigma m equal to 0. But remember, if you write sigma m equal to 0, just note, but we will call sigma m, note. It is sigma mz equal to 0. Just a note. Because some people I have seen, they write sigma fx 0, sigma fy 0, sigma mz 0. Why use z? Not required. Sigma mz means about a point. See now, I will dictate here. Algebraic sum, go that side. Okay. Algebraic sum of components of entire force system, all the forces of all the forces, components of all forces of the force system, all forces along xx is 0. Now, sigma fy 0, you only write. Algebraic sum of components of all the forces along yy equal to 0. Sigma m0 means algebraic sum of moments of entire force system, color I am changing, see, entire red color I write, force system to important system about z axis, don't waste time, about any point which you take. I am telling it 100 times now. If you take any point means the moment is about an axis perpendicular to the plane. Don't write it. About any point in the plane. Any point in the plane is 0. For sigma fx 0, sigma fy 0, to ensure there is no translation. Sigma m0 is to ensure there is no rotation. Okay, these are the basic conditions of static equilibrium for coplanar force system. Now, I am going to end the class now because there is some problem here in the power. If I continue, power problem is there. I doubt very much will the power will last for another 10 minutes or not. So little short I will make today after a long time. Next class what I will do is, for a coplanar force system, I will divide into 3 parts. For concurrent, general coplanar and parallel. Then in the entire board, I will write summary. In the summary, I will write 3D and 2D both. In 3D, 6 conditions. In 2D, 3 conditions. In 2D or coplanar, separately I will write for concurrent, coplanar, general coplanar and parallel force system. Okay, I will end the class because it is running on UPS here. Any time power will go. I know power is very less. Even battery also very low level. Some problem, because of rain, some problem was there. Therefore, I am going to end the class now. Next, in lecture 2 of part 2, class number 43, I will continue and give all the explanation Remember earlier long back what all I explained for moment about axis and point, study once again. For that matter, study everything. Okay. Now, we'll meet in the next class. Thank you.